Hi, welcome to reading quiz number 12, the chain rule. The chain rule will be one of the most important rules that you'll learn in calculus, as it will help us find the derivatives of composite functions. And you will see composite functions all over the place, and therefore the chain rule will be especially useful. So what is the chain rule? So, it will be one of the more frequently used rules to find derivatives in this course, as I said. It is also one of the most challenging rules to learn because you have to recognize and be aware of hidden inside or composite functions. Right? Other classes have found this to be a little challenging. You are not, of course, other classes, so you will be able to breeze right through this. The rule states that if a function g is differentiable at x, and if f is differentiable at g of x, and h of x is f of g of x, so a composite in other words, h prime is equal to f prime of g of x times g prime of x. Using Leibniz notation, if we were to write y is equal to f of u and u is equal to g of x, in other words, y is equal to f of g of x, then we would have dy dx is equal to dy du times du dx. And note that this corresponds to the formula we've got up here above. Dy du is equal to f prime of g of x, and du dx is equal to g prime of x. So let's start with a simple example. Let's suppose that f of x is equal to sine of x squared. Find f prime of x. So this is a little bit trickier. This is not saying that f of x is equal to sine times x squared. The x squared is an input to the sine function. This is a composite function. The outside function is sine of x. The inside function is x squared. We can rewrite the function f of x is equal to g of h of x if g of x is equal to sine of x and h of x is equal to x squared. So I'll let you think for a second as to why this would mean that f of x is equal to sine of x squared. The rule would state that f prime of x would be g prime, derivative of the outside function, of g prime of h of x times h prime of x. So let's take a look at this. The derivative of the outside with the input still the inside function times the derivative of the inside. In this case, g prime of h of x would be cosine of h of x, in other words, cosine of x squared, and h prime of x is equal to 2x. So, let's think about this. Outside function, sine of x. We take that derivative first, leave everything else alone. Then we take the derivative of the inside. It's like you're peeling away layers of an onion. Start with the outside, take the derivative of the outside, and start moving inside and take the derivatives as you progress. Thus, our final answer is 2x times cosine of x squared. Written right here, it's a little bit easier to see. Cosine of x squared times 2x. The derivative of the outside function, which is the derivative of sine, leave the inside alone, don't worry about it just yet, times the derivative of the inside. That gets its own special place right here. Let's try another. Suppose y is equal to x to the fourth plus 3x squared minus 2 to the fifth. Find dy dx. Well, our outside function can be figured out if we rewrite h of x as x to the fourth plus 3x squared minus 2 to the fifth. Our outside function is something to the fifth. We'll call that f of x. And our inside function is g of x equal to x to the fourth plus 3x squared minus 2. Outside function, something to the fifth. Inside function, x to the fourth plus 3x squared minus 2. What do you think we're going to start with as far as our derivative? You got it, the outside function. H prime will be f prime, the outside derivative, of g of x, leave the inside alone, times the derivative of the inside, g prime of x. The outside derivative will be 5 g of x to the fourth, 5 times x to the fourth plus 3x squared minus 2 to the fourth. So this is all just the derivative of x to the fifth, except instead of x, we've got g of x on the inside. G prime of x will be 4x cubed plus 6x. And remember, we string it together with multiplication. We get h prime of x is 5 times x to the fourth plus 3x squared minus 2 to the fourth times 4x cubed plus 6x. I multiplied this last part by 5, and we get 20x cubed plus 30x times x to the fourth plus 3x squared minus 2 to the fourth. Should we step it up a little bit? Yes. Suppose f of x is equal to sine of cosine of tangent of x. Find f prime of x. That looks really intimidating, but in fact it's not too bad if you realize that we've got two inside functions we're dealing with here. Yikes. So we need to look at this as p of x is equal to h of g of f of x. One function inside of another function, inside of another function. It just keeps on coming. The derivative of this whole thing I've listed up here, p prime, would be h prime of g of f of x. So derivative of the outside, leave everything else the same on the inside, times g prime of f of x. So then we go to the first inside function, times f prime of x. All right? So we keep on unpeeling the derivatives, one part of the composition at a time. So h of x is the farthest out function, that's the sine of x. G of x is the one that's second farthest out, cosine of x. F of x is the most innermost function, which is tangent of x. So therefore we get our composition, p of x. Sine of x is h. Cosine of x is g. And tangent of x is f. So our derivative of the outside part, the first part of our chain rule, would be h prime of g of f of x, which would be cosine, the derivative of sine, of cosine of tangent of x. Remember, leave everything in the inside alone. G prime of f of x would be negative sine of tangent of x. And then derivative of tangent of x is just secant squared of x. And then we just put it all back together. P prime is cosine of tangent of x times negative sine of tangent of x times secant squared of x. The reason it's called the chain rule is because it's like links in a chain. We're putting it all together into one big chain with multiplication. So, looking back at the Leibniz notation, it looks like it's a little bit challenging at first, that dy dx and dy du and all that. But it really isn't that bad. If y is equal to f of u and u is equal to g of x, meaning that y is f of g of x, then dy dx is equal to dy du times du dx. Now the reason for this is a little more formal than we're going to get into, but one of the things that you can notice here is that the du is a go-between here, all right? It's not necessarily that the du's cancel out, all right, but they balance each other out here. So that when you look at the one in the numerator and the one in the denominator, all you're left with when you match the two of them up is a dy dx. So let's say, for example, y is equal to f of u is equal to sine of u, and u itself is x squared, which means that f of x is equal to sine of x squared. Now, we just saw this example just a minute ago, right? And we had a particular way, we had the formula to figure out that derivative. Well, if you look at it this way, we can see that dy du is equal to cosine of u, and du dx is equal to 2x. So that when we apply Leibniz's notation to this, we get dy dx is equal to dy du times du dx. dy du is cosine of u, and du dx is equal to 2x. Well, what do we know that u is equal to? U is equal to x squared. And we can plug that in, and we get the same answer as before, 2x cosine of x squared. So the notation is just a different way of looking at things, and it kind of gives us a little bit better of an idea of what's going on, all right? That the u is basically a placeholder in this case. Oh, our tables. So let's use the table of values to find the derivative of a given point. Let's say r of x is equal to f of 2x plus g of x, and we're going to find the derivative at x is equal to 1. Remember, when you're dealing with tables and things of the sort, you need to find the derivative first, then plug in. Please do not plug in first. Well, first we need to figure out what our outside function is. That's our f of x. All right, that will go first as far as our derivatives go. The inside function is 2x plus g of x. Derivative of the outside will be f prime of 2x plus g of x. Remember, we're leaving the inside alone for the time being. And the derivative of the inside will be 2 plus g prime of x. We can string that all together, and we get f prime of 2x plus g of x times 2 plus g prime of x. And a straight mark there. Now we plug in x is equal to 1 to see what happens. When we plug in 1, we get f prime of 2 times 1 plus g of 1 times 2 plus g prime of 1. Just a little bit of simplifying here. We know that g of 1 right there is equal to 4. And we know that g prime of 1 is equal to 5. So when we plug in, we get f prime of 6 times 2 plus 5, which is 7. F prime of 6 is equal to 4. 4 times 7 is equal to 28. So remember, take the derivative first, then plug in. A couple of tougher chain rule problems. So let's say, for example, we wanted to find the derivative of f of x is equal to x times cosine of 1 minus 3x. Hey, we saw how to do these sort of things before. When we've got one function times another, x times cosine of something. It just so happens in this case that the cosine of something is going to be a trickier derivative to find because we'll need to use the chain rule for that part. So sometimes you need to combine the two. We'll let g of x is equal to x and h of x equal to cosine of 1 minus 3x. G prime of x, that's easy. That's equal to 1. H prime of x requires the chain rule, with the outside function being cosine of x. So derivative of cosine of x would be negative sine of 1 minus 3x. And then the trickiest part of them all, you need to be aware that there's an inside function here. That inside function is 1 minus 3x. The derivative of that is not 1. People rush to conclusions about that. Make sure that you are checking very carefully and are finding what the derivatives of your inside functions are. In this case, this is a linear function with slope negative 3. Therefore, the derivative is negative 3. When you put it all together, all right, we get 3 sine of 1 minus 3x. That's the h prime part. So it's kind of like being within a dream here. So we found the derivative of each of the parts of the product. Now we need to find the derivative altogether. Using our product rule, the derivative will be cosine of 1 minus 3x plus 3x sine of 1 minus 3 times sine of 1 minus 3x. 3x sine of 1 minus 3x. Sorry. One more example. Let's say you want to find the derivative of y is equal to the square root of x plus square root of x squared plus 1. Wow, that's a lot. So let's look at all the composites for this function. We'll let f of x equal to the square root of x. So the derivative is 1 over 2 square root of x. That's the big outside function. We'll let g of x is equal to x plus h of x. And h of x will be another inside function we deal with. So g prime is equal to 1 plus h prime of x. And h of x is equal to that square root of x squared plus 1, which we can rewrite as x squared plus 1 to the 1/2. This itself has an outside function of something to the 1/2. So the derivative will be 1/2 x squared plus 1 to the negative 1/2. And then it has an inside function of x squared plus 1. So that derivative will be 2x. When you simplify that, that derivative is x over square root of x squared plus 1. So here we go. The derivative will be f prime of g of x times g prime of x. F prime of g of x, we found out above, is 1 over 2 square root of g of x, which is x plus square root of x squared plus 1, times the derivative of g prime of x, which is 1 plus x over square root of x squared plus 1.